you haven't already, I just encourage you to read this problem yourself and sketch a picture and work on it some yourself before you watch through this video. I'm going to roll through this assuming you've given it some thought. So let's think about the situation. I think a picture is in order. So I'm going to imagine maybe the ground is right here, and I'm going to put a dot there, and that dot is going to represent my radar station. And I'm going to go up. Let's just draw another dotted line. This is going to be, we said, I'll just draw a line straight up. And it says plane flying along passes a ground radar station at an altitude of 1 kilometer. So this is 1 kilometer. And then at that point it begins to climb at an angle of 30 degrees. And so the plane is somewhere here. We'll put it at that dot. And this particular angle is 30 degrees. And then it says, at what rate is the distance from the plane to the radar station increasing 1 minute later? And so we're, of course, interested in that distance right there. You can use different letters. I'm going to call this length x and this length y. And so let's think about what are we given. The plane is flying with a constant speed of 300 kilometers an hour. And so the rate of change of the plane here, the plane is flying along, that's going to be what? Well, you know that dx dt is 300. We're given that. Okay? And what are we looking for? Well, we're looking for the distance from the plane to the radar station. So we're looking for dy dt evaluated at the moment t equals 1. And so we'll think about how to use that information of t equals 1 a little bit later. I want to show you how to find the relationships here. And so you may have forgotten or never even seen the law of cosines. This is a really kind of special little rule. So let me review whoa. Let me do a quick review of the law of cosines. I'll do it in a different color so that it kind of stands out. So let's just say the law of cosines. There's actually 3 versions of this. We're going to write down a specific one, but I'll show you how you can get all of them. So you've got a triangle, not necessarily a right triangle, angles little a, little b, little c, and then I'm going to label the sides like big C is the side opposite angle C, big A opposite angle B, so on and so forth. The law of cosine says that you pick whatever side you're interested in. We're going to be interested in the c squared. Sorry, we're going to be interested in the side C. And you can say, well, c squared is a squared plus b squared. That's like the Pythagorean theorem, minus 2 times a times b times the cosine of the angle that you're opposite of. So C, if this is side C here, then it's cosine of angle C there. And so I want us to think about together how we can apply the law of cosines in our situation. So let's write it down. So I can say, well, y squared is got to be x squared plus 1 squared. All right, that's the first part. X squared plus 1 squared. I can do that. And then minus in 2 times x times 1 times the cosine of the angle opposite of y, because that's the one I've got along here. Well, this angle, if you think about it, this angle is 90 plus 30 is 120 degrees. So I'm looking at the cosine of 120 degrees. We usually work in radians, but I'll write it as degrees. And so I have y squared is x squared plus 1 minus 2x times minus a half. Or if you want, this becomes y squared is x squared plus x plus 1. Now that's a relationship that I don't expect you to have figured out on your own without me reviewing the law of cosines. That's a hard relationship to come up with, but the law of cosines is really helpful. Once you've got the relationship, though, taking the derivative shouldn't be any big deal. We're viewing, remember, y and x are functions of time. As time passes, these are changing. So I just take derivatives. It's kind of like what we did in implicit. In fact, it is implicit. The difference is I'm viewing both of these variables as functions of t. I'm not looking for dy dx. That's not what I want. I want dy dt and dx dt. And so when I think about that, I get a 2y times a dy dt equals 2x times dx dt plus dx dt, and then the derivative of 1 is 0. What are we looking for? We're looking for dy dt, so I want to get that by itself. We're given dx dt equals 300. And so if you want, we can actually solve for dy dt. So let's do that. Let's begin by realizing that 2y dy dt is the same as 2x plus 1 times dx dt. And so that means that dy dt, what we want, is 2x plus 1 divided by 2y all times this dx dt. Okay, so we found the formula. We're told this, right? We're told that dx dt is always 300. And so what we're interested in is, how do I figure out these values? And it all comes down to this line right here, 1 minute later. Okay? 1 minute later. So think with me. So after 1 minute, if we're flying 300 kilometers an hour, we can say, well, if 1 minute has passed, you've traveled 5 kilometers, right? That means, right, 300 kilometers every 60 minutes, which boils down to 5 kilometers every minute. So after 1 minute, x is 300 divided by 60, which is 5. So looking at our formula, x is 5. Right, you've traveled a distance 5 along here. Well, that tells you what y is. So if x is 5, y squared is 5 squared plus 5 plus 1. And you can take the positive square root. You get square root of 31. Not negative. Y is a distance, so y has to be positive. So I get y is square root of 31. Now I'm finally ready. I can say dy dt, the moment that 1 minute has passed, is equal to 2x. X is 5, so this is 2 times 5 plus 1 over 2 times y, which is root 31, all times dx dt, which is 300. And you end up with, when you simplify this, you get 1650 over root 30. I think that should be root 31, sorry. 1650 over root 31. And so that's it. That's the rate of change that we were looking for. Difficult problem only because of the relationship. This was a difficult relationship, but I wanted to work through it with you anyway. All right, so you've made it through these 4 examples. If you really want to understand this, you're going to need to spend some time working through those homework problems. So have a look at those, work on them, and then bring questions to class, and we'll go over them together.